Alright, we're going to take a look at the very last topic we have to cover for semester 2 for Algebra 1. And we're going to talk about rate of change. So we've seen this before actually with some of the other problems we've worked on, but we're just going to review it, so it's going to be a nice way to end the semester. So when we're finding rate of change, we're just looking for how things are changing over time. What's the difference from a starting point to the ending point? So here's an example of a graph of a helium balloon's flight. So over time, the balloon is increasing in height. So if I want to find the rate of change, to find the rate of change, you need to find two values or 2 points on your line or from the information. So for here, the 2 points we have are 0, 0. I added this one in because I know it's starting on the ground at 0 and the time is 0. And this one's given to us, 6, 6,000. So remember, average rate of change is just slope, where you take your y values and subtract them over your x values. So here I've got 6,000 minus 0 over 6 minus 0, which gives me 6,000 over 6, which is 1,000. So what does the slope or rate of change mean? It means the balloon rises (1,000 feet) for every 1 minute. So the balloon increases 1,000 feet for every minute of time that has passed, which makes sense given our graph here. Looking at the graph, when is the balloon at 5,000 feet? So I'm going to look at where 5,000 feet is and go over to time. That takes 5 minutes. When will the graph or the balloon reach 10,000 feet? So the graph doesn't show us that, but if we use our modeling, this line would continue on, and it looks like as you go up 1,000, you go over a minute, and that's what we calculated with our slope. So up 1,000 would be 7,000 to 7 minutes, 8,000 to 8 minutes, 9,000 to 9 minutes, so that means 10,000 is going to be at 10 minutes. Similarly, we can look at another problem involving money. So the following represents the balance in Alan's savings account. Find the rate of change. So when you have your graph, you want to find those 2 points that you can find the slope between. So in this case, the 2 points are 0, 300 and 12, 1,500. And we're going to do the same thing here that we did last time. We're going to take the y values and subtract them, divided by the x values subtracted. So 1,500 minus 300 is 1,200. 12 minus 0 is 12. Dividing that, you'll get 1,000. Actually, 100. Because 1,200 divided by 12 is 100. So what does this mean in terms of the problem? This means that the balance increases by $100 per every month, per month. So the balance is going up $100 per month on this graph. Looking at the graph, how much money did Alan have when he opened the account? So that's when we started. It looks like he had $300. At this rate, how much money will Alan have in 15 months? Well, we can continue the pattern, just like we did before. If it goes up 100, that'd be 13 months, so that'd be at 1,600. Up 100 would be 1,700, and that'd be at 14 months. And up another 100 would be 1,800 for 15 months. So he'd be at $1,800 after 15 months. Another way to look at it is that we know it's increasing $100 per month, and 3 months after 12 months is 15 months, so you just add $300 to 1,500. So average rate of change, remember, is just finding the difference between the y values over the x values. Let's look at some other examples. Here we're going to have to create a table and then graph it for the scenario that's provided. So Jessica makes $7 per hour babysitting. Create a table of values and graph for the scenario. So if Jessica doesn't work at all, she's going to make no money. If she works 1 hour, she makes $7. 2 hours, she makes 14, because we're just multiplying. 3 hours is $21, then 28, and then 35. So we can label the graph. The bottom will be our x-axis, and this will be time. So I'm going to do this in hours. And the side is going to be how much money she makes. And I'm going to go up by 5s. And this is her money. So plotting our points, we've got 0, 0, 1, 7, 2, 14, 3, 21, 4, 28, 5, 35. So we got a nice line there. So to find the rate of change, we can just use 2 of the points that we have on our table, and I'll use the ending point and the starting point again because that's worked out for us. So 0, 0, and 5, 35. So our rate of change is going to be 35 minus 0 over 5 minus 0, which is 35 over 5, which is 7. So she makes $7 per hour for babysitting. Other types of problems with rate of change will come in word problems. And we can see those with the bottom 2 problems. Same idea, we're looking for those 2 points that we can compare. So a nail salon opened in 2010 and had 1,200 customers for the entire year. In 2015, they had 3,200 customers. What is the average rate of change in customers with respect to time and years? So our 2 coordinates here are 2010 and 1,200, and 2015 and 3,200. So I just took that straight from the information. These were the 2 years together, the year with this date, or this information, and then the year with this information. So it's the 2 numbers that are together in the problem. And then doing slope formula, we take our y value subtracted over our x value subtracted. So 3,200 minus 1,200 is 2,000. 2015 minus 2010 is 5. So 2,000 divided by 5 is 400. So that means that they had an increase of 400 customers per year for their nail salon. The last example, we can look at this with house values. So let's say in 2008, I purchased a home for $150,000. So my first coordinate is 2008 and $150,000. In 2017, my house is reappraised, so my next value is 2017 for $245,000. Find the annual rate of change in dollars per year and the value of the house. Round to the nearest dollar. So I'm going to do my slope formula again where I subtract. So I am subtracting the values of the houses over the years. So 245,000 minus 150,000 is 95,000. 2017 minus 2008 is 9, so dividing 95,000 by 9, I'm going to have to round to about $10,556. So the average rate of change for my house was $5,556. So get some more practice with these review problems for your final as well as what we did some of this in first semester. So good luck.